What's happening, dogs? Mr. Allen here, and we got ourselves quite a bit of graphing to do of some linear equations in three different forms. We've got slope-intercept form, we got point-slope, and standard form. So let's tackle these first two right here in slope-intercept form. It gives us our slope and our y-intercept, hence the name. My y-intercept is 3, so I'm going to pop up here 1, 2, 3 on my y-axis, and my slope is -2, which means I'm going to go down 2 to the right 1. Now, a negative slope should always have this going down as we go to the right, whereas a positive slope will be going up as we go to the right. All right, and I can do another couple points if we want. Down 2 over 1, down 2 over 1. The more you do, the more accurate your line will likely be, or bust out a straight edge. You know, if you got one, that's always a good idea. I always carry a straight edge with me, right? Your ID, right? That will work. Boom. Nice line. I don't have that right now. I guess I do have a ruler. I could have done that. I do have a ruler, okay? But I'm a free-handed here, okay? Next one. Where is my y-intercept? Well, there's nothing there. It's really like +0. So we're just going through the origin on this one. And it's negative once again. It's going to be -5 over 3. Make sure that you don't go negative in both directions, because negative divided by a negative is a positive. All right, so we're going to go down 5 and to the right 3. Once again, notice how my line is sloping down and to the right, whereas up and to the right would be positive. All right, we'll probably get a positive slope here in a moment. So for this next one here, make sure that it is recording. Good, cool. Next one here, we got ourselves point-slope form. It gives you a point that's on the line, and it gives you the slope of said line, hence the name. Now, my coordinate here, my x-coordinate is going to be the opposite there. It's going to be -2, and it's going to be +1. The way that this form is written, I'll write it down here, is y minus y1 equals m times x minus x1, okay? So the opposite on both of those causes that sign change, all right? Whereas slope-intercept, I'll write it over here, y equals mx plus b. That's the general form there for the slope-intercept. All right, so we got -2, +1. That is my point that's on the line. And now from here, I can just go up 1 over 3. So I'll go up 1 and then to the right 1, 2, 3. Boom, there we go. We can even go down 1 and to the left 1, 2, 3. Right, you can backtrack in that way. All right, but both of them were negative in that case. Down 1, left 3, that's negative, which gives me that positive, wonderful slope. There we go. Cool. You could also rewrite that in slope-intercept form by distributing the 1/3, adding the 1. It can get kind of nasty, especially with this one, because you'd have fractions you have to deal with. See how we have a y-intercept that's between 1 and 2? So I'll just graph it like that. Cool? All right, they might ask you to rewrite it in slope-intercept form, but we were just asked to graph here. Next one, I've got myself -4 and -2. So 1, 2, 3, 4, -4 and -1. Uh-oh, I don't have a y scale here. One sec, one moment, please. My goodness. 1, 2, 3, 4, 5. Okay, cool. Boom. Near disaster. So we're at -4, -2. My slope is -3. So we're going to go down 3. So 1, 2, 3 into the right 1. Should be right here. Or I can go up 1, 2, 3 into the left 1. Because up and to the left would still give me a negative overall. And you can see how it is in line with it. There we go. Excellent. All right. Nice. It's a lovely little line right there. Last one, standard form. This is the one that doesn't actually tell you what you get right here. Slope-intercept form. Here, point-slope form. Standard form. What the heck does that give me? It gives me my x and y intercepts with a little bit of work, okay? So I can plug in 0 for y. That will tell me what I'm going to get for my x-axis, right? That's where it's going to cross my x-axis. Because if my y value is 0, then it has to be on my x-axis. So if I plug 0 in for y, I'd get 2x equals 6. We can solve that pretty easily. Divide by 2, I get x equals 3. So my x-intercept is at 3, 0. And then I can do the same thought process to get my y-intercept. Plug 0 in for x. I'm left with 3y equals 6. Divide by 3, I get +2 for my y value. Connect the 2 points. It's a little wobbly there. It's okay. And there we go. We got my equation, my line. I could have, subtracted 2x. Check this out. If I subtract 2x, I'd have 3y equals -2x plus 6. Divide both sides by 3, and I get y equals -2/3 x plus 2. My y-intercept is 2. I went down 1, 2 over 1, 2, 3. See? Checks out. even if I rewrote it in slope-intercept form, which is usually the preferred form here when graphing, dealing with linear equations. But standard form, it's got its helpful things here. Gets you your x and y intercepts quickly. Same idea here. Plug 0 in for y, so I got 4x equals 8. Divide by 4, I get 2. Now for this one, we often also call this the cover-up method. I don't know if I can cover this up here, but if I cover up the 4x, I'm left with negative 2y equals 8. Divide by negative 2, I get negative 4. 1, 2, 3, 4. Negative 4. Connect the dots. Whee! Sound effects encouraged. There we go, guys. That's awesome. We graphed 6 lines in 3 different forms. Hopefully now you're an expert in graphing lines. And remember this information because graphing lines never goes away. Okay? Algebra 2, you're graphing lines. Right? In pre-calc, you'll be graphing some lines. Calculus, AP Calculus, you'll be graphing some lines. Simple linear equations like these come back to haunt you in every single math class. Okay? So be ready for it because they're dope and you're dope. See you later.